All right, so today we're going to talk about surface area, lateral and total surface area of rectangular prisms. So what you'll notice here in your packet is that there's going to be 2 pages of notes. It's going to be one for notes and one is going to be practice that goes in our notebook. After that, then you have a page that you will work on your own, which is your homework page. All right, let's get started. So please follow along in your notes with this. And if you have questions, please ask the teacher. So here, surface area. Surface area is the total covering on the faces of a three-dimensional object. It is measured in square units. So that's like if I had centimeters squared. Examples of what the surface area will be like wrapping paper, or like when you're wrapping a present. That's the surface area, or the amount of cardboard for a box. All right, let's jump right on in. So we're going to use the dimensions of this rectangular prism to label the net, then calculate the area of all 6 faces and determine the total surface area. Well, remember yesterday we made our pieces. We cut out our parts. So for those that need the visual like representation, you can definitely pull those out. I'm going to pull mine out here. So we have a rectangular prism here. So I have a rectangular prism here. So if I was to assemble my rectangular prism, I can make it look just like it. According to this rectangular prism, the bottom here is 4, and this side at the bottom is 3. So even on mine, if I was to write 4, I'm going to write it in pencil so I can erase if I need to always replace my numbers with something else. Give me 2 seconds. And this is good for you too, so that if you struggle with knowing where does my numbers go on my shape, that's one of the reasons I gave you these. So if I have my shape assembled, I will see that I have a rectangular prism that looks just like this one. This right here is 4. So I'm going to write 4. And then according to the picture on this side will be 3. And then there's 11. So this will be 11. So I have 11, 4, and 3. So when I unassemble it, this one looks a little different because they put the base on the edge. But that's okay because your base can do that if you wanted to. But that doesn't change the fact that we know what the numbers are and where the numbers go. So here, I know that if this is 4, right here will be 4, right here will be 3, right here will be 4, right here will be 3. And we talked about that this is 11 because that's 11 here. So my 11 will go there. So let's go ahead and show what that looks like. So I'm going to just use some different colors. My 11 is there. So right here should be 11. My 4 is there. So on my base, my 4 should be represented there. And then my 3 is here. So on my base, my 3 should be here. But in reality, if my 3 is there, my 3 is also represented on the sides, the shorter sides. And if my 4 is here, my 4 also has to be represented here. So this will be 4, 4. And the reason I know that is that if I take my prism and fold it down, this side will match up. So if that's 3, this is also 3. If this is 4, then what's across from it should be 4. So if this is 4, this face should be 4. You see how that's working? This is why it's good for you to have these shapes so you can write all the numbers in to know exactly what goes where on here. And that's why I'm going to color coordinate it so you can see the 3 goes there, the 4 will go there, and this will always stay 11 all the way across. So now that we have that, so if that's 11, we know down here is 11. So now we have all these numbers. It's like, okay, what do we go from here? So I know if this B is here, I know that 3 will go here as well. And our 3s, because it's a prism and it's rectangular, so I should have 2 sides that are short with the 3s. I should have 2 longs with the 4s. And the 11 should go all across all of my things. So now we need to find the area of each one of these rectangles. So for here, 4 times 3, that's 12. And that's angle E. So at E, I'm going to put 12 centimeters squared. 4 times 3, because again, rectangles means base. The area is base times height. So each one of these, I'm doing base times height. So 3 times 4, that's 12. That's F. So I'm going to put 12 centimeters squared here. Then here I have 3 times what goes here. It's 11. So this is 3 times 11. Right here will be 4 times 11 because the 4 is there to represent it. And this is still 11. So this is 44. This is 33. This is 4 times 11, which is 44. And this is 3 times 11, which is 33. So when we look at it, this A is 44 centimeters squared. B, 33 centimeters squared. C, 44. And D, 33. Now remember, one thing we need to know about total surface area is that means that I'm just going to add all faces. Add all faces. So that's all of the letters A through F. When we add those together, we should get 178 centimeters squared. So it's 178 centimeter squared. Now, I know that seemed like a lot, but this is why I gave you the shapes beforehand so we can look at it and talk about it, because there's a shorter way to do that as well. And sometimes that just might mean that, well, we'll see. Let's keep going. We're going to decompose the net into shapes and complete the table to determine the total surface area of the rectangular prism. So again, if it's total, that includes everything. Nothing is left out. We'll talk about lateral in just a moment. So here they told us this is 3. If that's 3, then I know down here has to be 3. This is 8. I know here has to be 8. And so you can kind of go in and write what are they. So 3 times 8, because remember, all rectangles is base times height. This is also 3 times 8. So what do you think this measurement here is? Well, I know it's a 8, but it's not going to be by 3. It's by 15. So 8 times 15. Then this small space here will be 3 times 15. And then this space here, because it's bigger, it's going to be 8 times 15. And this small one is 3 times 15. So what are we noticing pattern-wise? When it's a rectangular prism, I will end up with 2 shorts and 2 long. So how do we do that? Well, we can take a look here and we can write in. So we know that in reality, there's 3 shapes going on here. There's the base. That's 1. So we can say base. There's the skinny rectangular prisms. Rectangles, the smaller rectangles. So we can say, like the small. And then there's the larger ones. And there are 2 of each one of those. And so when we think about that, when we think about the base is 8 times 3, which is 24. So each one of these is 24. So for each base, we're looking at area equals base times height. When I put the values in, I'm saying 8 times 3, which is 24. And it's not just 24 because it's another 24 because it's 2 of those. So I can always say, so this is 24. And so I can definitely say, so the area of just the 2 base, because there's 2 base, 2 small, and then 2 larger rectangles, I can say 24 times 2, which is 48. Then I have the 2 small rectangles. So again, it's area equals base times height, 3 times 15, 15, 30, 45. 15, 30, 45. So that's 45, but we have 2 of those. So I could say 45 times 2. And so 45 times 2 will, because wait, did I do that correctly? Yeah, 3 times. Yeah. So 45 times 2 is, what's that? 80, 90. And then for shape 3, the larger ones is still area equals base times height. And the larger ones is 8 times 5. 8 times 15. 8 times 15 is, let me see here. That's 120. And so when I already have 120, remember, it's 2 of those. So 120 times 2, that's going to be 240. So now I have these 3 numbers. I can go ahead and find the total surface area by adding them up. So I can say 240 plus 90 plus 48. So it's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 7, carry the 1, 3. So 378. So my total surface area is 378. And the unit that we're using is meters squared. So it says, what do you notice about the different faces of the rectangular prisms? Well, one thing I did notice about every face is that they are all rectangles. If they're all rectangles, I'm using the same formula as base times height. That's one of the best parts about dealing with rectangular prisms is that I can just know if as long as I can identify 3 different shapes, 2 base, 2 small, and 2 large, whatever I get, I can multiply by 2 and I can always get the total surface area. Make sure you get that written down onto your notes. If you need to start the video over to go back over a part, please do. Now we're going to move to the practice. It's going to be a little bit more notes and then practice for your notes. So you have 2 notes that's being glued in. And then after that, you move right into your homework page. So here, let's talk about lateral surface area. Lateral surface area is the sum of the area of the surfaces of the solid except for the base. So all that means is when I'm looking for my lateral is do not include bases. Do not include bases. Anytime they ask you for a lateral surface area, do not include base. When they give you a total surface area, so I'm going to go back to where we wrote total surface area. At total surface area, which they don't really say that on here for surface area, but I'm going to write it here. So for total surface area, we're going to say include bases. So for total surface area, we include the base. When it's lateral surface area, we do not include the bases. So let's go forward. Find the lateral surface area and total surface area of this prism. So remember, we talked about that every one of them will have 2 and 3. So for lateral, I don't need the bases, but for total, I will need the bases. So I'm going to say like no base, and I'm going to say yes base. So I know the difference. So let's go ahead and do the math. So in this square here, again, these are all rectangles, so we know everything is base times height. So I have 5 times 4.2. And when we do the math of 5 times 4.2, we get 21. So 5 times 4.2 is 21. Now, I know that there's another square that's supposed to be just like it with 21. So I'm going to write that there. Now I need to find it for the small one. So for this bigger one, I know that if this is 4.2, right here is also 4.2, right? This small one is 2.9. So here I'm going to say 2.9 times 5 because this 5 carries over all the way through. Think about it. If this side is 5, if I get 5 going this way every time, that tells me that every line in here has to be 5. I'm always going to get 5 there. So this is 2.9 times 5. 2.9 times 5, that is 14.5. And so if that's 14.5, this also becomes 14.5. So 21, 21, 14.5, 14.5. Now, for a lateral surface area, I don't need the bases. I can stop here and just write the lateral. So lateral will be 21 times 2 and 14.5 times 2. So I'm just going to do that. That's 42 plus whatever I get here from 14.5 times 2. That's 10, carry the 1, 8, 9, 2, one number behind the decimal. So that's 42 plus 29. 42 plus 29 is 71. So my lateral surface area is 71 centimeters squared. Now let's talk about total. Total surface area is going to be whatever I got for my lateral plus the bases. So now I got to think, what is my measurement of my base? Well, if this small side is 2.9, that tells me that this side also has to be 2.9. So this is 2.9. And if this longer side is 4.2, because that's what I used to get here, then I know this longer side also got to be 4.2. So I'm going to say 4.2. So what does that mean? I'm saying 4.2 times 2.9. 4.2 times 2.9 is, I believe it's like 12 something, but let me see. 4.2 times 2.9 is 12.18. So that would be 12.18 hundredths. So this also then is 12.18 hundredths. So now for total surface area, I got 71 plus 12.18 plus 12.18, sorry, 12.18. And when I add those up, I get, let's see, so 12.18 times 2, which is 24.36 plus 71, 95. So when I do that, I get 95.36 centimeters squared. Sound like a lot, but it really isn't. Now let's go ahead and talk about over here. What happens if I see it as a rectangular prism? Think about how many sides are on a rectangular prism. If I'm talking lateral of a rectangular prism, how many lateral sides are there? 1, 2, 3, 4. There are 4 sides, 2 of each type. So let's look at it from this angle here. So what would the measurements be for this side and this side? Well, if I know this little side is 2.5, that tells me here should be 2.5 times whatever the height is, which is 8. So that's 2.5 times 8. So this also is 2.5 times 8. Now, when I think about, so those are the short ones. What about the longer sides? The longer sides will be this bottom. So I'm going to use a different color to shade here. So here, for this side and the one on the other side of it, will be 4 times 8. And then I'm going to do that twice. So on the back side, it should also be 4 times 8 because it's on the other side of it. So I need 2 4 times 8s here, right? So let's do the math of that. So 2.5 times 8, 2.5 times 8 is 20. So right here, 2.5 times 8, that's 20. So right here, I'm going to keep track of what sides I got. I got 20 and 20. So that's 20 plus 20 plus, and now I need 4.8, 4 times 8. 4 times 8, for some reason, I feel like I don't know what that is, but I believe it's 32. So that's 32, and then plus 32 from the other side. So 32 plus 32. And again, you can just draw it out like this and work it from there if you need to. So now I have 4 measurements because this is my lateral. And so that's 4, that's 3, 6, 7, 8, 9, 10. So that means my lateral is 104 inches squared. My total will still be starting at the 104, but now I need to include my base. So I have 2 bases. My bases consist of 4 times this little space, so 2.5. 4 times 2.5. So when I think of 2.5 times, I think that's what, 10? So that's 10, and this is 10. So 104 plus 10 plus 10, that's 4, that's 2, and that's 1. So 124 inches squared. Let's do another one. All of the surfaces of the cube net below are being painted. How many square feet will be covered? So this is a cube, and I want you to do this one for yourself. Again, this is a cube. A cube means that they all have the same measurements. So if this is 4, this is 4, this is 4. If you got to go through and write 4 everywhere, then so be it. So now we know on the cube, everything has the same measures. Pause the video and go ahead and answer that for yourself. All right, hopefully you did pause it. So you would do it because remember, all area is base times height. Cubes mean that they're all same size. So from my net, I could say 4 times 4, so that's 16. 4 times 4, that's 16. This middle, 4 times 4, that's 16. 16, 16, 16. So I'm really looking at 16 times 1, 2, 3, 4, 5, 6, which will get me to 96 feet squared. If you got that, great. If you didn't, please try again. All right, now here is another cube. This time I'm not going to do it because hopefully we can see what I did here so that you could be successful here. Gerald is using butcher paper to cover 4 faces of the cube. If Gerald will not cover the bases, then how many square inches of butcher paper will Gerald need? So if he's not going to cover the bases, he's only covering the faces. And he's covering 4, but not. So what is he talking about? Is he talking about lateral or total surface area? So he's not covering the bases. So no base and no base. So how much of his cube is being covered? I want you to go ahead and do the math. Remember, these are cubes. If you need to redraw this shape and put this number on each one of them to do that, please do so. Pause the video, and then you can come back and see what we did. All right, so this should be lateral. And what I noticed here was that if I did 4 times 4, which is 16, and multiplied that by all the sides, because this was total, I got 96. So if this is still 6 sides, but I'm not including the bases, that just means I'm really saying 3.5 times 3.5. And whatever I get here, I'm going to multiply that by 4 sides. So 3.5 times 3.5 is 12.25. And so if each face is 12.25, that means 12.25 times 4 faces will be 49 inch squared. All right, last one. 2 students were asked to determine the total surface area of a rectangular prism. Neither of the students correctly completed the task. Determine what mistakes each student made and correct their work. So they needed to find total surface area of this shape. And we need to find out the area. Where the error was. So the total surface area, we need to find out how much. So first, let's find out what is the total surface area of this shape. So again, whenever I find one side, I know I'm multiplying it by 2, right? So I can definitely find the bases by saying 5 times 5. That's 25. So this base over here would be 25. So let's go ahead and do that. So that's 25 for bases. I'm put B. 25 times 2 will give me how much my bases are. And then I'm going to use S for my small side. So my small side is 5 by 11. So 5 times 11, which is 55. So that's 55 times 2. And then my bigger side was also a 5 times 11. So that's 5 times 11, which is the same thing as 55. So 55 times 2. And so 25 times 2, that's 50. And then 55 times 2 is 110. And this is also 110. So my total surface area is 270. So 270 centimeters squared. That's my total surface area. I'm going to say TSA, my TSA, total surface area. So if that's the case, let's see, where did they go wrong? So Tyson got 220 centimeters and they got 275. Anyway, I could have got 220. Well, yeah, if I look at my numbers, 110 and 110 for the short sides and the bigger sides, that would give me 220. So that tells me that Tyson, he did not include bases. Let's see about Bella. She got 275. I don't know what she could have did. Well, let's look. 275. That's 55. What did she did volume? Let me see. Yeah, I think she did volume because she just did 5 times 5, which is 25 times 11. When you multiply these, you get 275. So Bella did volume. All right. So hopefully we have enough practice that now you should feel successful to be able to do your homework. Again, go back and watch the video if you need it. Use your notes, use your little foldable. That's very helpful. And that's